This is Bukya Krishna, roll number 20951A2130, subject MTT, branch Aeronautical Engineering, Institute of Aeronautical Engineering, Dundigal. So today I want to discuss about Fourier transform in field of electrical and electronics engineering. Introduction. We obtain Fourier transform by a limiting process of Fourier series. Since it was first used by French mathematician Jean-Baptiste Fourier 1768 to 1830 in a manuscript submitted to the Institute of France in 1807. He said that Fourier transform is a mathematical procedure which transforms a function from time domain to frequency domain. Fourier analysis is useful in almost every aspect of the subject, ranging from solving LDE to developing computer models to the processing and analysis of data. The Fourier transform is a magical mathematical tool that decomposes any function into the sum of sinusoidal basis functions. The Fourier transform is a tool that breaks a waveform, a function or signal, into an alternate representation characterized by sines and cosines. Definitions of Fourier transform. The Fourier transform is a generalization of the Fourier series. It only applies to continuous and a periodic functions. We defined Fourier transform of a piecewise continuous and absolutely integrable function x of t by x of omega equal to f of x of t is equal to integration of minus infinity to infinity x of t into e power minus j omega t dt. Inverse Fourier transform. We define inverse Fourier transform by using Fourier transform x of t equal to f inverse x of omega f inverse of x of omega is equal to 1 by 2 pi integration of minus infinity to infinity x into omega into e power j omega t d omega. Applications of Fourier transform. The Fourier transform method is applicable in many fields of science and technology, such as application to IBVP, circuit analysis, signal analysis, cell phones, image processing, signal processing, and LTI system. So now we can discuss on a few applications. Circuit analysis. There are many linear circuits used in electronic engineering field. These circuits include various components like capacitor, inductor, resistor, etc. Every electronic circuit can be modeled using mathematical equations. So we can see the below figure where x of t is equal to actual signal applied as input to the circuit, y of t is equal to output of the circuit. Now to perform frequency analysis of the circuit, Fourier is used. Here we take one example. In this example we have to find output voltage V naught t by using Fourier transform. You can see the diagram where I of t equal to current source, I1 of t current flowing through resistor, I2 of t current flowing through capacitor, V naught of t equal to output voltage, I of t equal to e power minus t into u of t. According to Kirchhoff laws, I of t equal to I1 of t plus I2 of t, V naught t equal to I2 t, and E inverse t e power minus t into u of t equal to V naught t plus of V naught t. By taking Fourier transform, 1 by j omega plus 1 is equal to V naught into j omega plus of into j omega V naught j omega. By solving we get V naught j omega equal to 2 into 1 by j omega plus 1 into 2 plus j omega. Consider that is equation 1. By using partial fraction method, 1 by j omega plus 2 plus j into 2 plus j omega, we can get a by j omega plus 1 plus b by 2 plus j omega. Consider equation 2. By solving that we can get a is equal to 1 and b value as minus 1. Therefore equation 2 becomes 1 by j omega plus 1 into 2 plus j omega equal to 1 by j omega plus 1 plus minus 1 by 2 plus j omega. Put this equation 1 in put this in equation 1, we get v naught j omega equal to 2 into 1 by j omega plus 1 plus minus 1 into by 2 plus j omega. Taking inverse Fourier transform, we get f inverse of v naught j omega is equal to 2 f inverse into 1 by j omega plus 1 plus minus 1 by 2 plus j omega. V naught t equal to 2 into e power minus t u of t minus e power minus 2t u of t. Next application, cell phones. Communication is all based on mathematics. The communication includes automatic transmission of data over wires and radio circuits through signals. Cell phones are one of the most prominent communication devices. The cell phone is dramatically changing the way people interact and communicate with each other. The principle of people interact and communicate with each other. The principle of Fourier transform is used in signal such as sound produced by a musical instrument, for example, piano, violin, drum, and any sound recording can be represented as the sum of a collection of sine and cosine waves with various frequencies and amplitudes. This collection of waves can be then be manipulated with a relative array ease. Our mobile phone high performing Fourier transform. Every mobile device such as netbook, tablet and phone have been built it in high speed cellular connection. Just like the Fourier transform, humans very easily perform it mechanically every day. For example, when you are in a room with a great deal of noise, you selectively hear your name above the noise. Then you just performed Fourier transform. If noise and you selectively hear your name above the noise, then you just performed Fourier transform. Image processing. Fourier transform is used in a wide range of applications such as image analysis, image filtering, image reconstruction, and image compression. The Fourier transform is an important image processing tool which is used to decompose an image into its sine and cosine components. The Fourier transform is used if we want to access the geometric characteristics of the spatial domain image, because the image in the Fourier domain is decomposed into its sinusoidal components. It is easy to examine or process certain frequencies of the image, thus influencing the geometric structure in the spatial domain. In most implementations, the Fourier image is shifted in such a way that the DC value, the image mean, f into 0 f of 0 of 0, is displayed in the center of the image. The further away from the center an image point is, the higher it is its corresponding frequency. Conclusion. In this paper, we can say that the Fourier transform resolves functions or signals into its mode of vibration. It is used in designing electrical circuits, solving differential equations, signal processing, signal analysis, image processing, and filtering. Thank you.